Question 7 is on normal distribution. For all normal distribution questions, I highly recommend sketching out the distribution to remind yourselves of the possibility of symmetry. The mean of a distribution is at 0. We know that the probability that x is greater than 5 is equal to a, and the probability that x is less than negative 12 is b. Because of the symmetry of a normal distribution, we know that p of x greater than 5 is equal to p of x less than negative 5. And this entire area is also equal to a. From the sketch, we know that p of x less than negative 12 must be less than p of x less than negative 5. Therefore, b is less than a. In part B, 1. You're asked to find the probability that x falls between negative 12 and negative 5. We know that this tiny part here is b. We know that this bigger part here is a. From negative 12 to negative 5, this is this tiny part over here. So just by looking at it, we can already write down our probability. This is equal to a minus b. In part 2, this is a conditional probability. This probability is equal to p of x less than negative 5 intersecting negative 12 less than x less than 12 divided by the probability of negative 12 less than x less than 12. How do we simplify this intersection over here? We need to find all the values of x that are less than negative 5, but also has to be between negative 12 and 12. This means that the part that we're truly interested in is this tiny portion in between. So this can be simplified to p of negative 12 less than x less than negative 5. This is also why we have part B1. So usually if a question asks you to calculate a quantity in the previous question part, most likely you are going to use it somewhere in the question. This probability is a minus b as seen above. P of negative 12 less than x less than 12. We'll use the same principle here. The probability of x less than negative 12 is equal to the probability of x greater than 12 by symmetry. This part over here, that's b. So, if I am to sketch out this entire distribution, we know that from here to here, that's b. From here to here, that's b. The sum of the entire segment is 1. We're interested in the part right in between. Therefore, this probability is going to be 1 minus 2b. And this is the end of B2. In this part of the question, you're asked to consider a different distribution of mean 10 and variance 4 sigma squared. In other words, the new standard deviation is 2 sigma. You're also given that p of m less than y less than n is equal to 1 minus a minus b, as seen above. First off, this is very intimidating, and this part is definitely not easy. So, on the real exam, if you're stuck on this part of the question, please move on. It's not worth it. However, if you do choose to attempt the question part, remind yourselves of the distribution from part A. This is A, this is B. The 1 minus A minus B would be this part over here, right? This part is A, that part is B. The entire thing is 1. So it can be this region. So P of m less than y less than n is equal to P of negative 12 less than x less than 5. But that's only one possibility. Another possibility is when this curve reflects about this axis over here. So negative 5 to 12 is also another feasible option. Why is that the case? Because the probability that x is less than negative 5 is A. The probability that x is greater than 12 is B. And what's left is once again 1 minus A minus B. So those are the two options. Now let's go back to our question. We know that P of m less than y less than n is equal to P of negative 12 less than x less than 5. This is going to be our first option. This means that when we normalize, they should have the same z-score. So let's normalize this. Normalizing m, we will get m minus 10 divided by 2 sigma less than z less than n minus 10 divided by 2 sigma. On the other hand, we'll have negative 12 minus 0 divided by sigma and 5 minus 10, 5 minus 0 divided by sigma. 0 is the mean of x. This guy is the mean of y, just to remind you. Therefore, n minus 10 divided by 2 sigma is equal to negative 12 divided by sigma, and n minus 10 divided by 2 sigma is equal to 5 divided by sigma. In other words, n minus 10 is equal to negative 24, and n minus 10 is equal to 10. So m is negative 14, and n is 20. This is the first possible scenario, which is also part C1. C2 asks for the other possibility. So we'll do the normalization process again. But this time, x is between negative 5 and 12. Normalizing this, we'll get n minus 10 divided by 2 sigma is equal to negative 5 divided by sigma, and n minus 10 divided by 2 sigma is equal to 12 divided by sigma. Now we just need to solve for m and n. M is therefore 0 and n is 34. So those are your two possibilities. This is the end of question 7.